Okay, welcome to the first screencast for Guidesheet number 2. In this case, we're going to go beyond distance and displacement and tie those into the rates of change, known as speed and velocity. So we'll try to figure out how those are similar and how those are different. The one URL is shown here from Physics Classroom that covers this topic, and the kinematics concepts are levels 3 and 6. Okay, a quick review. A quantity, a blank quantity, is completely described by magnitude alone. So magnitude alone would be scalar. So we can measure it with scale. It just has a value, a magnitude, no direction. A blank quantity is completely described by a magnitude with a direction, and that would be a vector. So in this case, it is the scalar, ignorant of direction, doesn't really care about direction, just need to know its size, and then the vector, which has to have direction to completely describe it. Now, speed is a scalar quantity. Your speedometer can measure the speed. It doesn't tell you what direction it goes, it just tells you how fast you're going. And velocity is a vector quantity. So at least VE, vector, and velocity go together. So again, it's scalar then vector. Okay. Alright, now, looking at situations where we can compare speed and velocity. So, speed describes how fast or how slow an object is moving. It is the rate of change. Again, that means we're going to divide something by time of distance. So if you're calculating your speed, you would want to take the distance that you've traveled. Now that includes back and forth, up and down, left and right. Take the total distance traveled divided by the total time. So rate means to divide by time. Velocity, on the other hand, is a quantity defined as the rate at which an object's position changes. Now that means it's really the rate of change of the object's displacement, which is a vector. Now you can move around a lot and still end up with a rate with a change of displacement of 0 or a displacement of 0, as we saw last time. If you come back to the same position and you haven't changed your position, then your displacement is 0, which means technically your velocity will also be 0. Okay, now those are very different concepts, so it's important to understand the difference between them. 3. Suppose you're considering 3 different paths. We've got A, B, and C. Along which of the 3 paths would you have to move with the greatest speed? Move the fastest to arrive at the destination, the second point, in the same amount of time. Now, speed, again, is distance traveled compared to the rate of distance traveled, so distance divided by time. All of our times are the same, so if we're going to cover more distance, we have to go faster. This is the shortest distance possible. This is slightly off of that. This, we are taking a convoluted path, so the answer is going to be C. We've covered the most distance in that time period. Therefore, speed, which is distance compared to time, has to be the largest for that particular part of the motion. So if you're going to cover a lot of ground in the same period that somebody else gets to take a shortcut, then you have to go a lot faster. True or false? It's possible for an object to move for 10 seconds at a high speed and end up with an average velocity of 0. That is actually true. Again, the key is that we're talking about the velocity. Velocity is not based on how far you've gone. It's based on your delta change of position. So if you go out and come back to the same place in the 10 seconds, then your change of position is 0, and therefore your velocity is 0. Not your speed. Speed would be a total running total of the two motions. It would not be 0. So speed and velocity are not, by no means are they always the same thing. So They are related, so they're similar, but you have to be able to pick out the differences. Um, in fact, I kind of jumped in addition of the. So say you move out from the your current seat, you pick up something on the shelf, you come back to your seat. That takes 10 seconds. Since you're back to the same position within the room that you started at, your velocity would be zero. Okay, now the next one we've got some paths again to look at. Some are straighter than others. Again, the shortest path between 2 points is a straight line. We're going to rank the 3 paths from lowest average speed to the greatest average speed first. Now again, average speed is just going to be the total change of distance per time. So the one where we're traveling the furthest would have the highest speed. The one where we're traveling the shortest distance would have the lower speed. So we're going from lowest to highest. So B is the shortest distance. C is a fairly short distance. Path A is a much more complex long distance. So it would be B, C, A. A would be take our highest speed for the same time period, 10 seconds. B wouldn't take us, we wouldn't have to go very fast at all to get to that, across that short distance. And C, again, not very fast because we're not going all that complicated. Now, if we're talking velocity, the answers are not going to be the same in this case. Again, that's the change of position. Now, this would have been the biggest speed, but its velocity, which is a vector, is 0. Why? Because we came back to exactly the same position that we started from. So this actually has a velocity of 0. Now, these two, we started from here, we went to here. If you look at that, those really look like the same position, or the same change of position. Looks like the same distance to the right. So B and C would actually be technically equal if we're talking about the velocity, because our change of position is the same. Then the A would be, in this case, the smallest, because A would be essentially equal to 0. So A is the smallest, B and C are essentially the same velocity because the change of position is the same. So, subtle things to work through, but very important to bring a complete understanding to being able to track more and more complex motions. Alright, so next time we'll look at calculating speed and velocity.